nobody said anything last week, so I didn't know.
I don't know anything about it.
This is today we have a test.
Next week. Did you get that other one?
No, not yet.
Okay.
Last night I went to bed about 2 a.m.
Yes, such is the life of a student.
I tried to finish your paper, but just done some of it. Yeah, I tried to get up with a psychology test tomorrow. Yeah.
Right. Okay. Yes. Okay, let's see. Okay, let's get out the, I want to kind of review some different things. Let's see. First, I want to just look at some things from the other chapters. Just a minute. Okay, before we get into what we were doing last time we were here, let's review just a little bit, because next week we'll have a test over chapters 1, 2, 3, and 4. We've only done 1, 2, and 3, and then today we're going to do 4. But on chapter 1, well, and also it goes back over the adding, subtracting, multiplying, dividing, fractions, decimals, and percents. But you can, you'll be able to use your calculator, on the test next week. Okay, but anyway, the main thing out of chapter 1 was inductive and deductive reasoning. And it's like, if we look at this one, every student taking Mr. Jones' math class works full-time as a minister. George is taking Mr. Jones' math class. Therefore, George is a full-time minister. Okay, that one is which type? Deductive. Okay. You can usually tell by the way it is written. Okay. This one here, the first one, is inductive because it is examples. Then we have problems. Well, you might have to write a sentence using a particular word, in 2 different ways. Determine the number that is next in the progression, and if it is arithmetic or geometric. Which one has to do with multiplying or dividing?
Geometric.
Geometric, right. And adding or subtracting is arithmetic. So you always just look at your pattern and see if you can tell if you're multiplying, if you're adding, if you're subtracting, what you're doing. Okay, so that's basically that lesson. And then, let's see, 1B, this is the same type of problems, and you did these. And the best way to study math, a lot of people will say you can't study math, but you can by working problems. And you work a problem that you have the answer to. And if you get the right answer, then you know you're doing it. And if not, then you got to go back and study some more. But anyway, so that's the same type of problems there. Okay. Then on chapter 1, if we had all these different problems with the same types of things, looking at things like this, which is a square number. And so if it's a square number, okay, then it would be like 1, 4, 9, 16, 25. And what it was like 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, so it would be 6 times 6 or 36. And so you just figure out what the pattern is and see if you can figure out what the next one that comes in it. Okay, so basically inductive and deductive. Then in 1 and 2 we had estimating, and we mostly looked at where you could estimate with money. And like on this one, they would estimate something like to the nearest 10 cents or something, or estimate it to the nearest dollar. And then then you just had to guess on those. And a lot of them, your answer did not come out anywhere near what was in the back of the book, and mine didn't either. You know, and you never know exactly how someone else is estimating. Then you had this type where you had to have like 1 inch is about 200 miles. And so you would get something that was about 1 inch, you know, and then you would do it like that and figure out how many of those that you had in there. This was a new type where you divided it into a grid. You counted the number of things in one grid and multiplied by how many grids that you had. Okay. Sometimes you had like these where you had like different circles and so many percent of the thing. And here's one also with retirement income. You've got 3%, 20%, 15%, so forth and so on. And they always tell you some number that you will be multiplying by in those. Same types of problems here. And then we did the problem solving, which makes sure that you understand what they're asking for, devise a plan to solve the problem, carry it out, and then check it and see if it makes any sense, okay? Because a lot of times you just get through with it and you're tired of looking at it and you go on. But if it's something that has to do with you and your money that you're spending, you know, you'll spend a little more time, you know, figuring that out. Okay. Mm-hmm.
This just caught my eye. It says a dime. Look at a dime. Around the edges of a dime are many lines. Estimate the number of lines there are around the edge of a dime. Punch themselves in the face. How do you do that?
Okay. Well, yeah, let me see if I've got a dime.
I'm sorry.
Sorry.
I mean, I can understand if it's like, you know, a square or a rectangle.
Right,
doing
right.
It that way, but
okay, they're saying if you can think. Okay, so here's your dime. All right, what I would do is divide it. You know, I mean, I hadn't even looked at that problem, but I would just divide it, you know, say 1/4 of it. And then, like, start up here at the top of the flame and then count so many around and multiply by 4, you know. Or you could even divide it into more, you know, places in that. But, you know, but it's kind of hard. But I could do it with my fingernail and fill them. 1, 2, 3, 4, 5, 6, something like that. Okay. That's the exact same type of problem. Okay. Good that you saw that. Okay. But you never know, you know, in your life what type of a problem that you're going to have to solve. Okay, this was one of those that was horrible, you know, where you had the one that you were doing was with cream of wheat, I think it was, you know, that you had to do. But they had so much for 2 servings and so much for 4 servings. So you would have to, like, multiply in order to get, this one was A, multiply the amount for 2 servings by 3. So you multiply that by 3, that by 3, that, and so forth and so on. And all you're doing is just little fraction problems, you know, to see if you can do that. And then they would get so many for 2 and so many for 8, and they would show you how to do it 2 different ways. You could add these 2 together and divide by 2 and see if it came out to that one, you know. So that's what you were doing with your, but just look at all the, I mean, you know, those kind of problems are horrible. But you will not have any like that, you know, on the test. I hate them. No problem. Don't know.
might be in there.
It could be. I don't know. Yeah, it was.
Where was you this morning? Texting me, or was that you texting me?
No, I did not text you.
You didn't text me? Oh wow, I thought I was texting you. Oh, good.
Don't know who you were talking to.
It must be David.
Okay. And it was kind of probably unclear. I mean, you know, about whether you were supposed to go to that or come to class or whatever, you know. But no one said anything last week, so I thought, okay, we'll just have it then. Okay, but if you have if you have a question on chapter 1, you can look at the review problems or the test, and the answers are in the back. So if you have one like this one right here, look at number 6. Okay, and you think, there's no way to figure that out. If you move them, you know, like this one and, you know, maybe one over here might make a whole one, you know. So you just estimate like you've got 1, 2, 3 whole ones, and then move, you know, like this one, you know, down here or right there, and then that would make another one, and then move this one. So you move them around like that and figure out what it is. Okay, then chapter 2 is what we did last week, which was sets. And a set is just a group of objects. And the only numbers that we talked about in this particular lesson are the set of natural numbers, which these are the counting numbers. It's natural to count with 1, 2, 3, 4, 5. So that's how you remember what the natural numbers are. And those would be the set that the answers would come from in most of these problems. Okay, now I want to look at, let's see, make sure you know all the words, you know, like a set, elements. Elements are just the members. Roster form is when you just list them and put the little braces on the side. Set builder notation is when it looks like this. And you have to know how to read that. Set A equals the set of all x, such that x is greater than 3. And then you might have to say, well, what does that mean? That means numbers bigger than 3, 4, 5, 6, 7, you know, and so on. Okay. The ellipsis are the 3 little dots. That means it never ends. Okay. Then we had like a finite set, which ends. It has just a certain number of elements, A, E, I, O, and U. Infinite means it keeps on going. And we had a problem that was like this, A, B, C, and so on, which was a tricky problem, wasn't it? Okay, because alphabet does end. Okay, so this one was finite, even though it had the ellipsis and it looked like it was infinite. Okay, let's see. Then we had equal sets and equivalent sets. Now, the thing about that is they are equal if they are exactly equal, exactly the same. Equivalent, they have the same number of elements. So this set is a set whose members are A, B, and C. This set whose members are 1, 2, and 3. They are equivalent because they have the same number. They are not equal. Okay, they do not have the same elements. Null set means the empty set. There are no elements in there. If I said the set of alligators in this room, there are none, hopefully. So it's the null set. And then a subset might look like this or like this. When you take the actual course, they'll distinguish between these two, and you have to know all that. But we're just doing a little bit of everything. But it is a part of a set. Like AB is part of this set right here. Okay. The intersection of two sets is where they come together. Okay. Find A, intersect B. This symbol stands for intersector. What do they have in common? It's like with a road. What do the two roads have in common? Union means to unite them or put them together. Okay. All right. Then we had Venn diagram, and I was looking at my grandson's health book. Hey.
I forgot I was supposed to be in here.
Okay.
A lot of story.
Yeah, right here and there. Sorry. But anyway, if you intersect the sets, it's where they come together. If you union them, you unite them, or it's all of them. Now, the hard part is figuring out where to put the numbers. Okay. But anyway, I was looking at my grandson's health book, and it said draw a Venn diagram like this and show where the attributes of smokeless tobacco versus like cigarettes, you know. And it would have things like, are they a carcinogen, you know, do they cause, you know, other problems. You know, it had a list, and so they had to actually put them in there. So every now and then you might have to use a Venn diagram for something. Okay. Now, let's look at this worksheet right here, we did a little bit, so we may have done all of it. Let me see, 16. But yeah, I think we checked this one last week. But let's just see without looking if you can remember how to read these things. This way you know how much you need to go back and study. All right, we read this. 3 is what? Element of set A. Good. 4 is not an element of set C. Now, let's see if we can read this. How do we start it? The set of all
X
such that
X equal to
good. The set of all X such that X equals 2. Okay. Are these infinite or finite? This one's 0, 1, 2, 3, and so on. Infinite. This one's the tricky one, A, B, C. Okay, it's finite because it does end in a Z. 1, 2, 3, and so on, 12. Finite. Okay, so just because it has the ellipsis does not mean that it's infinite. Okay, you have to look at each one. Are these sets equal? Are they equivalent? This one is a set whose members are 1, 2, 3. This one is a set whose members are 3, 1, 2. Are they equal?
yes.
Yes. Are they equivalent? No.
No.
Yes. Equivalent? This one has 3 elements.
Yeah.
This one has 3 elements.
I got it.
Equivalent means the number of elements. Okay. And in this case, they're also equal. All right, now look down here. X, Y, Z, and A, B, C. They're not equal. Okay. But they are equivalent. This one has 3, this one has 3. Okay. This one, the set A is a set whose members are 1, 3, 5, 7, and so on up to 15. So that means these are the what kind of numbers? Odd. Yeah, odd numbers. Okay, so is 8 an element of set A? No. Is 9 a subset of set A? Yes. Is it an element? Yes. Okay. Is 25 an element of set A? No. Okay, because it ended in 15. Okay. Then here's
the subset.
Uh-huh.
When we see the subset sign, I think I asked this last week. I couldn't remember your answer. When we see the subset sign and the element sign, they're basically the answer is basically the same.
right. The only thing a subset could have
They got more than one
one
element.
element, right? Mm-hmm. You're exactly right. Answer correctly. Here's 1, 2, 3, 5, and 7, 3, 7, 9, and 11. Okay. What is their intersection?
3.
Is that 7 behind?
Yes.
And
Mm-hmm. 7 and 7. Right. Their union? 1, 2, 3, 5, 7, 9, and 11. And we don't list them twice, the ones that they have in common. Is if the set C is 2, 4, and 5, what is the intersection of A with C? What do they have in common?
2 and 5.
2 and 5. Okay. Now I realize this is kind of hard to see. Okay, if C is 2, 4, and 5, what is the intersection of B and C?
3 is
Nothing.
None. Okay, and we would put the null set symbol. Okay. All right, now then we had where we had to draw some Venn diagrams. Okay. Well, if you look up here, I always do this part first and then intersect it with C.
that's what
This
I
one
had
union it
thought
and intersect it with C. Okay, let me look at.
I know, like in math, it's parentheses first.
Uh
But
huh.
for some reason, when I was doing this, it was just I didn't know.
Right. Okay. Anytime you have to do 3, right, do like A, B, and C. And it doesn't matter where you put A, B, and C, but most of the time they're going to be like that, you know. But you could call this one A and this one B and this one C, but everybody would be kind of strange. Okay. All right. Now, so let's say that A is 2, 4, 6, and 7. B is 1, 2, and 5, and C is 2, 7, and 9. What do all 3 of these have in common? 2. Okay, that's all I can see right now that they have in common. What do A and B have in common?
2.
2. Okay, so we've got to put 4, 6, and 7 over here somewhere. And at first, you're not sure where they go. Over here, we have to put, what, 1 and 5? Okay. C is 2, 7, and 9. Okay, now, there's the 2. The 7 needs to be there, right? So, see, sometimes you just start putting them, and then you rearrange them. And then 9 is down there. Okay, now, if I intersect A and B, that's that right there. Okay, and then I intersect that with C. Where does C come in contact with that part?
2.
Just at 2. So that is your final answer, 2. Okay. Now, if you do A union B intersecting with C, A union B, I'm not going to put the numbers in. Okay. I'm uniting them, I'm putting them together. Where does that intersect with C? Here's C. You see? You see C? Okay. So it would be
Or 2 and 7.
2 and 7.
Yeah.
If you put the numbers in there, it'd be 2 and 7. Okay. Now, if you have to do one like this, I'm not going to put the numbers in. A, B, and C. But it's A intersect B, union with C. I'm going to take this and unite it with C. So it's everything that's shaded on that one. Okay, this one, A union B, union C. Okay, so it's everything. Okay, now if you want to practice some of those, I'm sure there's some in there somewhere that you can work on.
Your lines are so much better than my lines. I put mine through.
Her circles are perfect. Mine look like Muhammad Ali did them.
I've had 100 years of practice drawing circles. Okay. Now the next thing is chapter 3 on logic. Okay. Did anyone bring me anything on MC Escher?
No, I remember it often in class. Are you going to tell us who he is?
See, all you had to do was look it on your phone
I
and
know,
go.
I forgot.
You know. Okay. All right. He was an artist, but I'm going to let you look up his pictures. Bobby's doing that now.
MC Escher?
Uh-huh.
MC Escher.
According to Wikipedia, Maurits Cornelis Escher, or commonly MC Escher, was a Dutch graphic artist who made mathematically inspired woodcuts, lithographs, and mezzotins.
The images.
It looks like he whipped that on acid and drew it perfectly. That's awesome.
I really like his
Picture.
That's pretty cool, man.
Okay. He did a lot of things. He did like something called tessellations. Now, this one is a perfect example of a paradox. You remember what I said, paradox?
Yeah, they're opposing.
Yeah, okay, and it can't really work. Mine's not coming up here. But it's the drawing of the hands. Now, some of you, I'm sure, have seen these pictures, but you didn't know who it was that drew them. Okay, maybe yours will come up faster than mine.
Here, scroll through them.
This one's taking forever. Yeah, now this is a tessellation. Okay.
That's really cool.
It's upside down. Okay. And he has a lot of them. It's like the fish, and then they end up turning into swans. You know,
Oh, wow.
like that. Okay, and here's the one with the hands. So one hand is drawing the other. You know, so that's impossible to do, but it's neat to look at. You know, that.
Oh, wow. Yeah.
Okay. And when I taught geometry in high school, everyone would have to make their own tessellation. And
Wow.
so you would, well, wait a minute, let me show you this. And here's some different ones. There's the ones with the fish and the birds. see them? And so they have to, we'd make one and then do like a poster board of the different ones. But what happens is you take a shape and then you cut off part of it and then add it to another part. And this is another really famous one. And it's these stairs. And you can't tell whether you're going up or down or sideways or what on these stairs.
Yeah.
You know? Okay.
It's like something in Hogwarts.
Yes, exactly.
That's the next one.
Yes, okay. I like that one, it's weird. And this one is a really good one right there too. Because if you look at the stairs on it, one way you look at it, it's going up, and another way it's going down.
Yeah,
This one
the
right
spiral case.
here. Yes, that one.
Oh, yeah, yeah.
Okay. Mhm.
Can you see?
Okay.
Can you see?
Is that the one you're looking at? I don't know.
Okay.
Huh? That is.
See, and the water will be flowing upside down, all kinds of stuff. But anyway, okay. But you needed to be introduced to him.
It definitely wasn't an engineer, that's for sure.
Okay, so we had a paradox, or it's a statement that can't exist, and that's the way, like the two hands, won't work. A simple statement is a complete sentence that has one thought but no connecting words like and, or, but, whatever. 5 is a counting number. Today is Tuesday. A compound has ands, ors, but, if then, if not, if and only if, those sort of things. A conditional is if it rains, then we will go. Here's another one that you can get extra credit on if you want to. Find me. You can do this on your phone, but if you want to. Almost all advertisements in the past were conditional statements. Okay, like in a magazine or something like that. So you need to find me a conditional statement. Now, because of people suing people, there aren't as many. You can't find them like you used to. I mean, when I taught this, years and years ago, every single advertisement was an if-then statement. If you use Pond's cold cream, then you will have blah, blah, blah skin. If you do this, then you will do that. And remember, you can add the if and the then to a conditional statement and
Same
make
reason
it
why
one.
doctors can't tell you anything in that.
Exactly, right.
Because you'll hold them to it.
Right, they'll sue you. I use this, particular thing, and I did not get more beautiful, so, Okay, then we went to where we had to use P's to stand for if and the Q to stand for then. And so, the if, like, if Sue likes golf, then Sam likes swimming. We put one line under the if part, 2 lines under the then. And we would represent that as P implies Q, or if P, then Q. Then we had to remember and was a caret, or was a V, not is a little squiggly line, means I am not going to town. But if you start off with a sentence, I am not going to town, to negate it, you would put another not in, which a double negative makes it a positive, so I am going. Then you have a biconditional if and only if. If it is Monday, if and only if I am tired. And the biconditional has an arrow a line with arrows on both ends. I am going to town, I am going to the movies. So, I am going to town and I am going to the movies. I am going to town or I am going to the movies. This one, if I am going to town, then I am going to the movies. Okay? This one, if I am not going to town and I am not going to the movies. Sometimes you start it and then you have to go back and kind of correct it, And so it would be, I am not going to town and I am going to the movies. I don't know how they're going to do that. Okay, but anyway, okay, right, exactly. I am going to town or I am not going to the movies. I am not going to town or I am not going to the movies. Okay, now this one. So you got an arrow in here. So it's got to start off with a if. If I am not going to town, then I am not going to the movies. And then you had, let's see, we did this one right here. We had to decide if it was simple, compound, or neither. And to do that first. Then you had to decide if it was compound, whether it was a negation, conjunction, disjunction, conditional, or biconditional. Now, I believe it's on 101 is the chart that you need, okay, to help you with your ands and your nots and your disjunctions and your conditionals and all those different things. Okay, so the first one, 2 is a counting number. Simple, okay, you'd like to have every one of them be that. Okay, it is not the case that Scott has a new car. What word in that tells you whether it is simple or compound?
Not.
Not. Good. Okay. So, it's compound because it has a not in it. Okay. Also, now it is compound. So, is it a negation, conjunction, disjunction, conditional, or biconditional? Negation. Good. You may attend the conference if and only if you have paid the registration fee. Simple or compound? Compound. What does that tell you? Biconditional. 2 ifs, so it's bi. Okay. Today is not a holiday. It looks simple, but it's not. It has a not. So it's compound and it is a negation. If Abby went swimming, then Julia went sailing. Okay, it's compound and conditional. If then is conditional. Where is your homework?
Nothing, it's a question.
Okay, neither one. All right, both Ruth and Florence are members of the band. What word tells you? Compound and so that is a conjunction. Okay, do you remember the conjunction junction? That's my function. Okay, all right. Either Bill is here or he did not come to school. What word tells you? Or. Okay, so that makes it compound. Okay.
Disjunction.
And disjunction. Okay, good. All right, and then we had to do the hypothesis with 1 and the conclusion with 2. Now, if you look at number 7, we will go skiing only if it snows. Okay, where is the hypothesis?
If it snows, is it hypothesis? If it snows.
If it snows, then we will go skiing is the conclusion. Okay, what's another word for hypothesis?
Theory.
Yeah, but there's one that might be on the test.
No, okay. Oh,
See why it's good to study? Antecedent. That's right. Antecedent. What is the conclusion? Another word for that?
Consequence.
Consequent. Mm-hmm. Right. Okay. Let's see. Trying to find this without the answers. Maybe it's behind. Yeah, it is. Okay. Just look at a couple of these and we'll get on to the other things. Okay. Today is Monday. Q is yesterday was Sunday. Writing words. Okay. Today is Monday and yesterday was Sunday. Today is Monday or yesterday was Sunday.
Today is not
Not.
Monday.
Monday and
yesterday was Sunday.
yesterday was Sunday.
So, very close there.
Okay, that means it's going to have a if then. If today is Monday, then yesterday was Sunday. Okay, this one is going to have an if then. It's also going to have So if today is not Monday, then yesterday was not Sunday. Okay, down here, it's going to be an and, this is going to be nots. Okay, today is not Monday, and yesterday was not Sunday. Okay. All right, that pretty much, I think, covers that. Let's look over here. This part. Did we finish these in class? I can't
No,
remember.
the first
Okay.
sheet we did. This one.
Okay, that's what I was thinking. We had done this. Okay, so get yours out so I can see if you have it. Okay. This is set 3, chapter 3, set 1B. Okay.
I forgot all my stuff. Should I go get it?
Yes.
I think we done this one.
It's somewhere.
Dog eat it.
You hope? That reminds me of excuses. One of my sons one time turned in his homework and the teacher said, I did not get it, gave him a 0, all this kind of stuff. Later, like, I think it was the next year, she moved her dryer. She had to buy a new dryer and there was his paper under it.
Oh, everything's already official. And everything.
Right. But I was appreciated that she did tell me.
Yeah.
That he got it. Did you find that one? Okay. Alright. If you find it before class is over, let me know. Okay.
I think I know where it is.
Okay.
In heaven.
No.
Hopefully there's no homework in heaven.
Can I go check too? Is it crucial?
Hurry.
I just wish I could not forget something.
We had to memorize a whole lot of formulas and stuff in logic class in Christian school, and so some of these symbols are familiar to me.
That's
It's a
good.
refresher.
Right, yeah. That's nice when you can refresh and not have to do it completely on your own. Let's see. Okay.
Do you know Jody Apple? You know him?
I know the name, but I don't know if I've ever met him.
Okay.
But I know
Well,
who he is.
he does International Gospel Hour,
Uh-huh.
and he was one of our instructors. He's a super smart guy,
Uh-huh.
and he taught our logic class.
Well, that's good.
He gave us 3 or 4. His classes were the hardest ones over there.
Right.
Him and Dr. David Locke was over there
Yes,
too.
I know him. Yeah.
And, they had,
He used to be here.
yeah,
Mhm.
he's the one that actually, he's the director over there. I was at what was formerly East Tennessee School of Preaching, now Southeast Institute of Biblical Studies. And Dr. Locke's the one that got them to be accredited. So
Oh, okay. Good. Uh-oh.
which is good, but you can't really build off of it because it's a regionally accredited bachelor degree as opposed to a nationally accredited bachelor degree. So that's the reason I'm having to go here. We'll work on my extra credit on there, Joe.
This one's nice with phones.
We had a couple of weeks where our internet wasn't working in the church office, and I had to go back to my. I like to look at Greek studies and stuff. I don't get into it during classes because
Right.
but just for my own personal study. And I had to use the actual lexicons and everything instead of just go into computer software.
Yeah.
I was like, man, this is.
Going back in time,
I'm
but
spoiled.
you never know, do you?
You never know. That's why I'm glad I have the books.
Right.
Because a lot of my preacher friends that are roughly my age, they don't really have a whole lot of books in their office. They just have their computer and they have all kinds of digital books and whatnot. That's dangerous.
I like real books.
For me, I like to see. It's encouraging to me to see how far I've gotten, and how far I got to go when I'm holding the book. You know, whenever I have like a computer book, it's like you can't see that. So.
Right. True.
Phrases.
I don't know if they were going all the way back to their apartment. Is that where they
Well,
were
always,
going?
always to the.
Yeah.
Okay, to the dorm.
you were
Okay. I was hoping it was just to the car. Okay, we'll go ahead and go over the answers to this, and then I'll show this to them later. Okay, on number 3, you had to tell if it was a conditional, negation, conjunction, disjunction, or biconditional. So A was a conditional and a negation. B, conjunction. C, disjunction. D, biconditional. E, conditional. Anybody have any questions on that? Okay. All right, F, conjunction. G, conditional. H, biconditional. I, disjunction. J, conditional, but also a negation. So it had 2 on that one. All right, write these in symbols. P, and this way Q, then a little arrow, Q. This one with the 2 arrows. I with the V. And J is not P, then not Q. Mm-hmm.
It took like 2 seconds
Okay.
to do number 4 because all you have to do is look over at your answers for F through J, and then
Right.
I got on symbol.
Is that all of them on that
Yeah,
one?
that's all of them.
Okay. All right, okay. Y'all got hundreds on your homework. Okay, let's see. Get this back together here in a minute. All right. Okay. Now, let's see. We're going to take some notes on chapter 4 in a minute when they get back. And there he is.
I lost some pen. Anybody have one I can borrow?
Got an extra.
And a pencil. Not a pen, a pencil. Okay.
Yes.
Found it. Somewhere in there. There we go. Very good. Okay. Makes a difference. You can take 100 and 50.
And the way my last test looked, I needed the homework.
Bobby's not as organized, I guess. It's taking him longer to find it.
Yep.
Okay, and we're gonna take some notes on chapter 4. Okay, so we're gonna be on chapter 4, which is systems of numeration. Okay, have a lot of interesting things about, you know, Mayans and Egyptians and people in Great Britain, Stonehenge, things like that. Anyway, all these different ancient civilizations came up with math, you know, because sometimes you think, who started this junk? Okay, every civilization did. Okay, they had a little bit different way to write it and keep up with it, but it's more of an international language than anything else is. You know. But we have different systems of numeration, and the first one we're going to talk about is the additive system. Okay, the additive system, if you look at it, we're talking about Egyptian hieroglyphics. Okay, and if we want to write the numeral for 600, we would write 6 of those little things, whatever they are. Okay, so on the next page, this is Hindu Arabic, which is what we use. Okay, the Egyptian symbols and the description. Okay, personally, I'm glad I did not have to do math in Egypt. Okay, so number 1 is the same thing basically. It's a staff or a vertical stroke. A 10 is like a heel bone or an arch. Okay, 100 is this little scroll or a coiled rope. 1,000 is a lotus flower. 10,000 are little pointy fingers. Okay. 100,000 is a tadpole or a whale. I think that's funny. Couldn't find it?
Aw.
Aw.
I'm sorry.
Oh, well.
I think I threw it away on accident.
You'll come across it, I'm sure. Anyway, we looked at them.
Can I write it out real quick?
Okay. Yeah. You can write down. And then if you find it, then just bring it next time.
Yes.
Okay. All right, and what we're doing right now is taking notes on chapter 4 on additive systems. Okay, I love a million, an astonished person. You know, it's going, ah, it's a million. You know. But anyway, so if you have to write the following number as a Hindu Arabic numeral. Okay, so you got 2 pointy fingers, so that's 10,000 plus 10,000 right here. And then you've got 4 coiled ropes, so that's 100, 100, 100, 100. And then 2 little vertical staff things. Okay, so you add all that up, and it's 20,402. Okay, now if you go back the other way, if you have to do Hindu Arabic 43,628, that's 40,000 plus 3,000 plus 600 plus 20 plus 8. Okay, so 40,000, okay, there's 10,000, so you need 4 pointy fingers. Okay, you need 3 little lotus flowers. Okay, and 1, 2, 3, 4, 5, 6 of the scrolls, or 600, and then 20 of the heel bone, or the arch, and then 8 of those. Okay, now, this part will not be on the test, okay? But you will need to work some of the problems so you can see how to do it. The next part, Roman numerals, will be on the test because that is something that we encounter every so often here in our society. Give me an example of where you see Roman numerals sometimes.
Preaching in an outline.
Okay, outline.
Movie,
Yes,
movies.
Almost all movies, when it tells when they were made, it's in Roman numerals.
If you have to
Okay.
read old, what is it, primary source documents back in maybe early 18th century, you'd have to understand them too.
Okay. And something that we see even more than any of those are clocks. Okay, a lot of those, you know, that way.
Also,
Okay.
a lot of older maps.
Mhm.
tell what year,
Yes.
you know.
Mm-hmm. So every now and then you will see this. Now, to refresh your memory, because if you're like me, you know, if it's been a while, you forget. But the V is a 5, X is a 10, L is 50, C is 100, D is 500, and M is 1,000. Okay, now, so these, it says this is the Roman system, and it has 2 advantages over the Egyptian. It uses the subtraction principle as well as the addition principle. Okay, and so if we have a smaller number to the left of a bigger number, then you're going to subtract. Okay, now let's see. Let's write this one as a Hindu Arabic. So you've got 2,000s, 300, 50, a 10, and 2 ones. So you write them out and then come up with the number. Okay? Here's one that uses the subtraction principle. You've got a D, okay, which is 500, a C, which is 100, an XL. The X is smaller than the L, okay? The X stands for 10, and the L is 50, so that it'd be 50 minus 10, or 40. And then a 5 and a 1, so that's 646. So be careful when you see one that is a smaller one, because otherwise they go down, you know. Okay, write 289 as a Roman numeral. Okay, so you've got a 200, an 80, and a 9. So you need 200, which is a C and a C. 80 is a 50 plus 10, 20, 30. Okay, so 50 and 10, 20, 30. And then you need a 9. So that's an IX, or 1 from 10 is 9.
The only ones you would combine the two would be 5 and the 1s, right? You would never combine, like if you're doing 9, would you do a 1 and then an X?
9,
What about an 8? Or is that
Okay.
be a V
Be
and
5 and 3.
3? So you wouldn't do an X and 2 behind it, just 1.
Just 1 behind it. Now, this is something I had never seen before until I taught out of this book. Okay, y'all may have. If you put a bar over a number, it means to multiply it by 1,000. But I had never heard that before. So, if you want to write 5,000, that's a V with a little bar over it. So that means 5 times 1,000, or 5,000. Okay?
It's a lot more efficient than writing M.
Right. And then X with a bar over it is 10 times 1,000. CD, okay, that's a small one in front of a big one. So that's like 400. 100 from 500 is 400 times 1,000, or 400,000. But I had never seen that before. Okay. Now it says write the number 33,888 in Roman numerals. And let's see, I don't know if it had that in there. Okay. Alright, so I did like, well, you can't see this, but I've got like, okay, 33,888 in Roman numerals. So if I did 10, 20, 30 times 1,000 is 30,000. Okay, so that's something totally different from the way I've ever done this. And then you've got 3. You could do a 3, okay, with these over it. So that's 3,000. Okay, and then you've got let's see, 888. So that's a D. Okay, 500, 6, 7, 8. 80, okay, is a 50, 60, 70, 80, and 8. 5, 6, 7, 8. That's long, isn't it? Yep. Okay, now, that's terrible to do that. And on the test, you would not have one. I don't even think I have one with a bar over it. Okay, just normal Roman numerals will do it. Okay, look on page 170. Okay, this is multiplicative symbols. Okay, those two are additive. You added the numbers together, but some of them you had to subtract. Okay, all right. But if you did the multiplicative system, okay, and it says right here, okay, the number 642 is 6 times 100, 4 times 10 times 2. Okay, so you would write it down like this. Now, this one is Chinese. Okay, and so this stands for 0. Can you imagine having to write that? I cannot imagine. Okay, and then 4 and 5, and look at 100 over there. Oh, okay. So you've got, if you want to write the number 20, you would have to put 2 times 10. So 2 on top, and then this down underneath. There's 2 times 10 is 20. 400, you would have to write a 4 times 100. Okay, so write 538 as a Chinese numeral. Now, it's easier to do this than it is to go backwards and do this because we've got to write all these squiggly things. Okay, no. Only Roman numerals is the only thing that'll be on the test
What?
from this chapter.
Why is this in here? What's the
Okay,
tagline?
we'll get to it in a minute.
I'm sorry.
Okay, right. You have to understand all these different types of systems, and because what we're going to do next, you'll need to be able to think that way. Okay, so on 538, 500 is 5 times 100. So there's a 5 and there's 100. 30 is a 3 times 10. And then an 8 is just an 8. So you put it down. Okay, and you'll have a couple of these to work out, but they can even have you add them, subtract them, multiply, and all that. We're not going to do that. Okay, next we have ciphered systems. Okay, now this is something you see. It's the Greek, Ionic Greek numerals. And if you have something, you can see 1 is an alpha, 2 is a beta, 3 is a gamma, so forth and so on. But then they also have different symbols for 10 and 20 and 30 and 40, 60, all the way up to like 900. Okay, it says since the Greek alphabet contains 24 letters but 24 symbols were needed, the Greeks borrowed these 3 symbols from the Phoenician alphabet. So the number 24 is 20 plus 4. When it is written as a Greek numeral, the plus sign is omitted. So 20 is the kappa, and then the 4, okay, is the delta. And so you just put them together. Now the number 996 written as a Greek numeral is like a pi and then I guess it's a cough or something, and whatever that is right there. Okay, 6.
Those are all Phoenician.
Right. Okay. Now it says when a prime is placed above it, it multiplies the number by 1,000. So if you have a beta, which is a 2, and put the prime, that means 2 times 1,000 or 2,000. If you have this one, which is 200, it's a sigma, times 1,000, it's 200,000. Okay. Now, we're not going to do all of these. We're going to do a few of them so that you can figure out how to do it. Okay. On 4-1, okay, we're going to do 9 through 11, 13, 15, 21, 23, 25, 27, 29, 33, 37, 45, and 47, 61, and 67. Okay. Now, that looks horrible, but it could be much worse if you had to do the whole thing. Okay.
Sure.
So just selected problems on that. Okay. Now, let's see. Let's go ahead and take a break right now, and then we'll come back and try to work on these.
I slept so long and so hard last night. I think it kind of messed me up today.
Not used to the feeling anymore.
I was at a friend had a crisis in the night, so I pretty much stayed up all night.
Oh, man.
And yesterday I kind of knuckled through it to get through work, and man, I got home and I was out.
Oh, what kind of advertisement were we looking for again? Conditional advertisement.
Hmm.
Is that what you said? For
Yeah, if you can find a conditional advertisement.
Found one of Carl's Jr.
Okay, what does it say?
It says, if it doesn't get all over the place, then it doesn't belong in your face.
Perfect. Okay. We'll have to read that one too. I'll put that down for you. Next test.
Yes.
Or do you want it on your last one?
Put on my last one.
Okay.
Yeah, that'd be great.
If you can come to our forum, which is next next Tuesday night, then you can get 3 points added for this.
Oh, there you go.
Okay. Well, it's not a forum, it's a seminar.
Okay. Is it here?
Uh-huh, yeah. And they feed you.
Oh,
And you can bring your girlfriend.
Yeah, I'll bring her with me.
We're gonna have barbecue.